Yeah, so welcome to the Frictionless call once again. And Keith, the floor is yours.
All right, it's good to see everyone. So I'm Keith. I'm a postdoc at NIH and NCI, and I've been kind of following this project and been involved for like 4 or 5 years now, and also really excited about it and the potential. So today, despite the holiday, my presentation is actually going to be pretty straightforward and unexciting, but it's basically just kind of thinking about the future and starting a discussion about some things that could be useful to sort through now. So with that, I'll get started. Hey, can you all see my screen?
Yes, and I love the title.
Yeah. So this is, for those of you who are around, about 1.5 years ago, I gave a presentation that was also the same kind of thing, just a conversation of ideas and kind of architectural things that we could consider to make the project robust and flexible, often having to do with like supporting a wide range of data types. And so it's basically a continuation of that discussion and some other ideas that I've kicked around in the past. So first, though, the motivation. The year is 2050. Data package has succeeded beyond all of our wildest dreams. Data package extensions exist for data types across a wide range of fields. What does this world look like? So this is kind of the motivation is like right now we're in the early stages and we have some extensions. Peter has created one for CamTrap DP that is fantastic and a good model. But in the kind of ideal scenario, one can imagine that we'll have many more specialized standards for different data types and used in different fields. And so it's going to be important to, both encourage that kind of grassroots bottom-up approach, because that's ultimately, how things will get done. And people are only going to solve the problems there where they need to solve something. But at the same time, I think it's useful to look at things from the other end and imagine like what would be an ideal structure and organization that we would like to arrive at. Because there is a risk that if we leave everything completely open, kind of do a grassroots, that you're going to end up with a lot of different approaches and people solving the same problems and not being able to communicate across the standards. So that's sort of the motivation behind this. I originally was going to try to cram a whole bunch of things in and pared it down to, I think, what should be pretty short and hopefully straightforward. So I'll talk about the structure and domain kind of division and our approach to organization. And then a little bit about like community repos, just kind of pushing on this idea again. I originally wanted to talk about composition, so constructing kind of composite data sets. The CamTrap DP standard is already an example of this, where it describes several kind of tables grouped together in a format. But there's related the data DAG presentation I gave a few years back. I think there's some interesting things we could do to allow people to more precisely define relationships between elements within a data package. And I have some ideas on that, but I'll save that for another time. So structure versus domain, just to remind people kind of what I'm referring to here. And we've talked about this a bunch, but there's also a lot of new faces. So when I say structure, what I kind of mean is like the format of the data, like or the nature of it. Is it tabular data, a matrix, image, spectral, audio, or any of these kinds of things? It could also be, natural language or graphical data. And then domain, when I use that term, what I'm referring to is kind of like the subfield. So where the data is coming from, what it's about. And these can be both like field specific. So you can have, data that is within biology or physics or econ, but then there's also domain, or what I would call domain elements that are shared across fields. So things like time, space, and units are useful to talk about in a whole bunch of different fields. But still, it's specific to certain data types, right? It's not necessarily structural either. Although I guess time time series data could be thought of as a type of structure. Okay. So structure, I would say from my point of view so far, again, like most of the focus on the project has been on tabular data or data frames. There are other formats that people commonly use, and it's just useful to think about it. And the question I guess we could ask is, would we encounter any issues if we tried to adapt the specs and libraries to work with these data types today? So if you were to take like the Python frictionless framework, which is, I think, kind of the flagship one and the main one that people use and we put effort into, and you were to try to create data packages where instead of tables, you were to have like any of these types, would you encounter any problems, or would, there be some kind of friction, so to speak? To give an example, and this is kind of what motivated this, some time ago, matrix data is one of the most common forms that we encounter for processed genomics data. And to give you an example, when I say matrix, and it looks like a table or a data frame at first glance, right? They're both rectangular, they have rows and columns. But the differences are for matrix data, in the kinds that I typically encounter, the values are all the same type, often numeric. And then the features can be different instances of the same thing. So like if you have a table in econ or survey data set, right? You might have your features or your columns are different variables, and some might be categorical, some are numeric, some are binary, and so on. But they could represent very different things. With a lot of the kind of bio and genomics data, you're just they're like multiple instances of the same thing. So different genes, for example. And often, and this is kind of an unfortunate consequence of history in this field particularly, because bioinformatics, we deal with these like tables of 20,000 genes, people decided to invert the matrix. And so instead of having the variables along the columns, we actually often have them along the rows. So that just complicates things a little bit more. So you can actually take this kind of data and feed it to Frictionless Describe, and I've done this in the past, and it works. But the result's not optimal. So if you have 20,000 genes, what you get is it'll infer a schema, and it'll have 20,000 values that should be the same thing if it gets it right. But it's redundant, right? You're not learning anything new, because you could just say that once and say, this is the type. So what would be better, in my view, would be something like this, where you just indicate the value type of the entire matrix, and then maybe something about the row type and the column type. So the rows are corresponding to genes, and the columns are corresponding to patients, for example. So if you were to provide this information, then one can start to imagine like how you could build systems to interact with these data sets and do useful things. If they know that the features are genes, and they know something about what identifier scheme is used, then they can start to pull in other types of information and provide more context, for instance. As an aside, as I'm kind of thinking through this way of how we want to handle data and kind of approach things abstractly, this paper came out earlier this summer, and I think it's one of the better things I found for trying to describe different types of data from an abstract point of view. So this is not covering all types of data. It's kind of biased towards things that people encounter in machine learning, but it covers a lot. And I think it does a pretty good job of describing like different types of data. And so they break it up into data as coordinates in space. So it's literally, each point is a point in space. So it could be like a point cloud or measurements on a flower. They give this example and so on. And then they also talk about data as signals, where this would be kind of the points are on an abstract embedded space instead of an actual physical space. And then there's some kind of measurement. But anyway, just pointing this out in case people are interested in this. It's Sanborn et al. Okay, so that is structure. So yeah, main thing is just that it could be useful to think through these. And I'm also happy to help at this point. I haven't done too much on the code base in recent years because I've been focused on other things. But I think, if I'm arguing for all these things rather than have someone else do the work for me, I'm happy to contribute too. So we can talk about this. Although Evgeny is not here, I guess. Is he still going to be involved in the project a lot? you mentioned he's going to take a step back.
I think is going to take a step back from the Python framework, but he was interested in maybe picking up the work with JavaScript. So we'll see. But Evgen is not at Open Knowledge Foundation anymore, but he's still like part of the data package working group, of course, and he will still be around.
Quick
Okay.
question.
There's
Heath, sorry to interrupt. Do you think a picture or an image is a special case of a matrix, like a matrix of RGB?
Yeah, I think it's one form.
triplets?
I think it's one form. Just one moment, please. So
Okay.
my power just went out, so I might have to cut the presentation short. I'm on a UPS right now, but I actually don't know how the internet's even going. Is it? Maybe it's just the, no, it's definitely the power. Let me check the breaker real quick. I'll be right back.
Yep.
All right, well, I guess I'm sorry, I'm gonna pass on the question because I'll probably lose power in 5 minutes. So let me power through this, then we can discuss it in Slack. And if I go before then, apologies. It's a sunny day, so I don't know, it's something in the neighborhood. All I was gonna say about domain is the extension mechanism is great. I had the first chance recently to sit down and actually look through it and see how the implementation is working. And I couldn't find any problems. So the challenge, I think, going forward is maybe growth and coordination. So it's this idea that I talked about of attacking things from both ends. So both supporting the individual efforts to come up with specific standards and then occasionally meeting to discuss. So form subgroups. Phil, you and I should get together and start thinking about the bio stuff and anyone else involved. We could meet, the domain-specific groups could meet on some frequency to coordinate and plan things. And then once, a few times a year, we could have a larger meeting where people get together and share their own progress and think about whether there's areas we can combine efforts and kind of agree on things that we want to be able to communicate about. Just examples of things to consider. So the name, like if you want to call a collection of specs related to some specific domain, you could give it a name, what kind of data types you want to cover, the data structures. So it's good to look at what's being used already. So in bio, again, in genomics specifically, summarized experiment in bioconductor and data in Python and Seurat, also in R, are examples of data structures that could be useful to look at and model things after, and at least communicate with. Ontologies and control vocabulary. So the ISA investigation study assay in bio is a good place to start. And then ontologies, we can also think about linking to ones that are useful. Website and branding, it'd be good to have or think about how we want to present these different domain-specific extensions. One could imagine creating like a tidyverse style little cute packages with different domain icons on them. And then the last thing is basically just to ask if anyone wants to take a stab at this thing that we've talked about before, which is to create like a community repository where an open source server where people can host data packages, and then it would provide some API to query and serve them. And then on the flip side, you can imagine creating a command line to list your kind of local data packages, search the known remote repos, and then pull data, show data, or launch a REPL in R and Python or whatever. And so I'm happy to meet with anyone who wants to try to tackle this and initially just set kind of a low bar and create a prototype. So yeah, two sides, a daemon and maybe a client to interact with it. And then I'm using Conda in my mind as an example of what I would kind of model things after. So Conda, you can specify repos you want to query. And I guess the Linux package managers are similar, right? There's the kind of main supported queries, but they often have like a community repo as well. So users can add repos that they trust. And so this would allow us to have like a decentralized nature where universities or organizations could set up servers to host data. And it could be domain specific, just the things they're interested in, or it could be a mirror of all the data that's out there, whatever. Low-hanging fruit version of this would be to scrape and compile known packages off of GitHub and Zenodo, create a static file, and then the client could literally query that file and then know of some data that it could pull. So this would be like a serverless approach, but not a good long-term thing. And then, yeah, I'm also interested to discuss this with people if they're interested. So I think it'd be great to have a site to support data curation. So where people could take data sets that are public and that are useful, analyze it kind of themselves or process it themselves, and then share it back. And then you could have for data sets multiple versions of different people's takes on it and some kind of mechanism to vote for ones that you think are well done or useful or, yeah. So get away from the idea that there's just this one version of a data set to having a more crowdsourced community approach to data curation. And that's it. I don't know how the internet's still working because the router seems to be off.
We can hear you just fine though, so I mean a miracle.
Oh, you know what? The router is actually hooked up to the power supply, so it'll definitely go out soon. Any questions before I disappear?
Be quick. Peter.
Yeah, some great examples and ideas here. The distributed part, a search interface where you can find all the packages. That sounds like a fun project to build. And I mean, others have done it before. It's like you detect a certain file in a repository across all of GitHub, all of GitLab, all of Zenodo, and then you list a registry of all of those, and then you have a common interface to all of that. So that seems, I mean, it's probably more complicated than WinVision, but yeah, that would be really showcase all the data packages out there. So that's something I would be interested to look for funding. And then for the community related aspects, yeah, it's the tidyverse one that is still managed by a kind of a single community. While here, I think, yeah, it's a bit of decision like how people are just going to take data package and do their own thing without maybe connecting back to the data package community. So yeah, it's going to be tricky to find a good balance between how much of it won't be centralized and brand as a common thing, and how much of it is, let's just do other people do their own thing, and if we know about it, link to it saying, hey, this is one of the adoptions. And I have a good example of that in addition to ChemtraDP. Now, the Global Biodiversity Information Facility is going to really build on data package to do stuff, and that's going to live in their own environment. But yeah, that's, and finally, the thing with matrices and other data formats, I think that's something that should be tackled, as you say, by a community who's super interested in doing that, which through the extensions you can really build. It's, I think, at a point when an extension becomes mature enough that you can think, oh, this would actually make sense for more than this community in a bio community, but in general for anybody who wants to do matrix data, to then bring it back. But I also really like things experimenting and developing in a small community, and then that being brought back to data packets if it's general enough. So yeah, very cool ideas.
Yeah, I think you're absolutely right. Like I'm kind of suggesting we have this level of organization and coordination and kind of thinking forward about how things might look down the road. But at the same time, yeah, I think now it's still early. It's only going to happen through the community down up. But yeah, maybe just do a little bit of both when we can and kind of keep in mind that larger structure in the end. All right. Well, I should probably just power off soon. I'm happy. Oh, sure. Peter?
Very quickly, you mentioned Spectra. Did that mean chemical and sample spectra. That's sort of another use of the word spectral.
Yep, exactly. That's what I have in mind. So it could be
Uh,
from
well-
like chemical mass spec or space imaging, different things that generate spectral data.
Right. On the chemical side, I've been involved with that for many years, and we're actually discussing it yesterday in Cambridge, where people are trying to do this under the label of FAIR data, FAIR data, with a standard for how you deposit it, but it is early days.
Yeah, I mean, I know of it. I've worked with it a little bit, but it's definitely not something I'm an expert in. So we can
Oh,
maybe
okay.
borrow your insight
Yeah.
when we get to it. All right, I should power off, but sorry for the disruption, and thank you all for the patience and for bearing with me as I rush through the slides. I'll check Slack from time to time, so anyone has questions or ideas or wants to work on something, just reach out. And otherwise, hopefully I'll see you next week with more consistent electricity.
Thank you,
Take care,
Keith,
all.
very much for your presentation. And yeah, let's continue the discussion on Slack.
Bye-bye.
There's a couple more things that I wanted to bring up. I don't know if you wanted to discuss more what Keith just presented. Without Keith, which is a bit unfortunate, but
Yeah, I have a question. So if we really want to support communities branching of data package, I mean, we have the standard version 2 now, but I think it's probably going to be necessary to have regular meetings of the working group in addition to community frictionless calls. So we can see if things trickle back to, oh, this could be part of data package as a common standard that we can tackle these. And I mean, how often to have this meeting could be quarterly, for example, to like dedicate that we know, okay, that's a time of the year to dedicate to some of the issues and work through that. Because yeah, as you noticed with the comment from GBIF, responding in time is a big aspect of how it is seen as how useful it is to invest in something. So yeah, I think having regular working group meetings for the standard is going to be critical.
yeah, I totally agree. But would you see that as so having several different working groups kind of like led by different people, maybe domain specific, and then having this kind of like central call, as you said, once every 4 months or something like that?
What the community groups, the extension are going to do, we have no control over that. It might include people from in this call here, but it's going to be spin-offs and they're going to do their own thing. But they are going to have questions sometimes for things that they want to add to data package common, not as an extension. And we need to have a mechanism in place to respond to those timely. So that if we know that we have a quarterly meeting with the working group, that they also know, okay, well, we will discuss this at the next. I'm saying meeting, it could also be a sprint, for example. We're going to discuss this at the next sprint. So they know, okay, this is something that's going to be tackled, because the people doing the extension or community-based work, they don't necessarily have influence over the timeline and the roadmap for data package. So that is why they need to know, okay, how quickly are these things going to be solved for us?
Yeah, very good point, Peter. Nick, you wanted to add something?
Yeah, I just wanted to talk from personal experience working on the open source community for climate change. What we're finding is that we have projects that are sometimes commercially driven or funded by governments or so on, and we quickly advance some set of functionality. And meanwhile, there's a stream of open source activity that's occurring. And so the intent is to take that activity to commercialize parts of it and then to contribute changes back. And it's important, to Peter's point, to do that in a timely way, because there's kind of a tax involved. The longer you wait, the harder it is to contribute upstream. But also, if multiple people are trying to solve the same problem and it makes sense to do it upstream, then the quicker the upstream can incorporate that, the better. But even when they do that, then there's a cost to the people who are, working downstream to say, am I willing to make these changes now so that I'm aligned with what's just happened? Or is it sufficiently different still that, I'm not willing to do that? And so this is the classic open source. But what seems to be happening that's a benefit is to have regular meetings, which we often do, then have side meetings with people who are working on certain things to try to push stuff back to the upstream on the regular meetings, and then to bring it back downstream. So it's complicated. It takes a lot of effort, and I call it a tax because it's something that's regularly paid, but the taxes often get you the things that you want that you wouldn't otherwise get. So taxes aren't necessarily a bad thing. And that seems to be what's that model. We're trying to contribute stuff. For instance, we're adopting frictionless, and I just keep talking about it. And I'm actually building frictionless schemas. Nobody's told me to do this, but I'm doing it. And we'll contribute that back to the upstream. But hopefully people will then use that in other projects that they weren't considering. But if they suggest things that are missing and create an extension or whatever, I will have to make a decision about whether I want to adopt that. So that's a good position to be in, but it's something that we have to be aware of. Hope that makes sense.
Yeah, absolutely. I'm thinking maybe Evgeny should be included also in this conversation to see like his take as well, but it's something that we can continue thinking on Slack. I definitely think there's some value on keeping like having a timely meeting like this one in which things can be brought up. But maybe I'm also like I would like to balance that with like acknowledging that people also don't have so much time. So if we have like separate meeting with working groups, maybe then that becomes also too much. But we can try stuff out as well and see what works, and we can adjust as well.
Between raw information and useful information, there is a conversion necessary. For example, temperature, body temperature, I need to know it is Celsius or Fahrenheit. And I need, at the end, I need a scale of how far is it fever and how strong is the fever. Dus that is not a linear relation. I need a conversion. Other problem is there are several classifications of disease in hospital or in general practice. They use today different systems, more or less precise. And dus I need to prefix any information to say, well, this is referencing to that given table. And very, very large domain, it must be open data and open source, of course.
Yeah, Peter.
Are you referring to that you want to indicate what unit was used for the temperature, or do you want to use a reference library or reference a definition for that specific temperature? Which one of the two are you discussing?
I need a conversion because what matters is there temperature and how strong is the temperature elevation? That is what matters. And that maybe is it a kind of true false 0 to 1 value at the end.
I'll try to answer in the chat.
And another aspect in medical information, you could have a very, very large table with many large column and rows. And I am interested in Neo4j graph database because any node can be linked to any node in a large space of millions of nodes of concept. Millions of concepts can be linked to concept, and the relation between concepts can have some attribute.
I don't know if someone has any insights from it, and sadly, I don't know really how to help on this specific case. So Etienne, Peter is, I don't know if you noticed, but he's writing something in the chat.
Yeah, I've tried to answer both questions in the chat, but it's a very specific use case, and I don't have all the information, of course.
But what you intend is globally interoperability.
Yeah.
I think you could also potentially put like RDF identifiers on your data package columns, like, and then you could have a whole relational RDF network to map between concepts, and then if we connect that back to the presentation, if we have a Conda like package management utility for data, you could query data sets for a particular concept and then get a bunch of columns that are related in a particular way.
Yeah, but RDF can be converted in Neo4j. But the reverse is not true, because Neo4j has more possibilities of qualifier.
Maybe one thing that I would suggest you, Etienne, is that maybe we can keep on this discussion also in Slack. Maybe there will be like more people that are more familiar with like vocabularies linked to the medical domain. I can put a link in the chat. I think it's already up there somewhere, but I'll put again.
And of course, I need spoken language independence. In principle, the concepts are what we need, but well, maybe we need it, but I don't like linguistic project, because in a given language you do not have an exact one-to-one correspondences in other language. Of course, the work is in English, but my basic language is French or Dutch.
I see that, Phil, you have your hand raised. I don't know if you wanted to react to that.
Yeah, just briefly, I'm having a little problem sort of the conversation I think is touching on a number of different things, and so I'm having a little bit trouble sort of following it. But so I think possibly in kind of Slack or different form I might be able to contribute more usefully. But just super quickly, so as Peter indicated, you can of course represent a graph database by just essentially having tabular resources as the nodes and using what Peter indicated to sort of link to those things. And a concrete example of this is that we produce. I'm going to toss a couple things in the chat here. We produce a software framework called Gen 3, which basically allows you to create data commons and data meshes and so forth. And the default data model, at least for what we refer to as the phenotypic data there, that default data model is a graph model, actually. And there is a way of dumping all of those data into a format called, let me drop it in here, called PFB, which is essentially a way of representing. It's based on Apache's Avro format, but it's a way of essentially representing graph data pretty efficiently. And one thing that we have added now is a way to go between PFB and frictionless. So it's very easy to go from a PFB file into a frictionless package and vice versa. That's very useful. Those are often primarily used in our cases for medical data of various kinds. And so I don't know how far that sort of addresses one of the questions, but it may address some of it. And then finally, this is a semantic search engine that sits on top of one of the sort of use cases that we're applying this to, which is basically all of the data, the NIH-funded data that addresses. Well, it comes under what's known as the HEAL project. So that's an acronym that stands for Helping to End Addiction Long Term. That last URL I gave, I think, has got some HEAL stuff there if you're interested. But it's on the order of 800-900 now, all funded NIH projects that look either at pain research or at opioid misuse, prevention, or treatment. So all in the sort of the medical domain. And that semantic search engine allows you to sort of search medical concepts, and that is built. That entire thing is built on top of schemas of data sets that we have actually collected from those investigators. So basically what we have them do is to submit to us frictionless schemas, tabular resource schemas, and they either submit them in that format, or if they don't, we coerce them into that format. But and then we feed that information in, along with, of course, a bunch of other information to generate that search engine. But it's an example of, I think, also of taking, the frictionless, the data package concept, and linking it pretty tightly to, in this case, semantic search. But so that stuff is very, very loose and may or may not be related to Etienne, what you're talking about here. But I'd be glad to talk about that more, concretely in Slack.
Thank you, Phil. And Etienne, if you're not on Slack yet, I added a link to join the chat. Maybe we can have a conversation then. Maybe, as Peter says, we should even open a health channel, as it seems that this is the focus of interest of a lot of you. We have 10 minutes left, and there's a couple of things that I wanted to quickly talk about, but I don't know if anyone had anything else that they wanted to talk about today.
Well, I had one question. I'm very interested in collections of documents, which I'll call corpora, particularly in climate. Does frictionless apply to bundles of documents, or can it be extended to that if the documents have appropriate metadata? Or is it pushing it too far?
It's a good question. Peter, yes.
I think that is technically possible because a data resource can be anything. So it allows you to have a data package and at least describe all the elements that are part of the data package. And a data resource, I mean, the most known one is of course a tabular data resource, but it can be any resource. So I would say that the document works there as well. I don't know if data package is the best fit for that. I think data package would be a good fit if you indeed have, for example, tabular data, but also documents, and you want to link those documents as part of your data package. And it's also not going to be able to provide that much in-depth metadata about that document, other than, of course, the description, the title, the contributors, the license. So your typical metadata, which can be different for that document than for your data package as a whole. So yeah, technically, if you have a path to your document and you want to describe it with some metadata, then a data resource would work. The software that is going to read a data package is just going to know, oh, this data resource exists. It's probably not going to be able to do more with that because most of the software that goes deeper into data resources are for tabular data. That makes sense.
Yeah.
And Nick, did you want to add something to that?
Yeah, just quickly. So we're trying to make climate data easily findable, and we need standard taxonomies to do that. You know, list of IPCC scenarios, and what are the hazards, what are the hazard indicators, what are the asset types and classes, and things like that. And one of the things that we see all the time is we have to point to GitHub repositories where code is. We have to point to Jupyter notebooks. We have to point to startup documents and so on. So the thought that we had was to kind of create standards where those things are present, if they're present, that you could put a GitHub URL in there, you could put a pointer to a Jupyter notebook. And so our thinking behind how Frictionless would work is that if you're building such an application, you want to bulk import all this information from a CSV file to get you going, then it would be good to have a frictionless schema that says, thou shalt have a column called GitHub repository URL, and then it can validate whether that is present or not. So that it's kind of loosely coupled, but it supports that notion, I think.
Yeah, so you can have, a metadata schema on top of this, which is quite well controlled and often fairly rectangular.
Yeah, exactly. For instance, it could have you could have a description of a list of these documents and how they relate to each other, and information about the publisher and the version and things like that. And you just make sure that when you're describing it, that those things are present.
Yeah. So, I mean, we have a tool. All our tools are open, of course, which can search the open access literature on Europe PubMed Central, and it creates a table of down here individual papers, and across the metadata, perhaps up to 50 different aspects of each paper, which allows you then to search over the metadata.
So Peter, the other Peter wrote a comment in the chat that could be.
I did the same thing. It's Zoom is very clunky. Peter Rust, I think you were replying to Peter Desmet, but you.
I'm sorry.
No, it's fine. I then commented back to Peter, but not to you. So anyway, sorry for the confusion.
Okay, sorry, then I missed something. But yeah, I think in summary, a data package JSON file can be your entry point to any file that you, or any collection of files that you want to make discoverable, or if you want to describe metadata. I mean, typically we think about it as data files, but it could be documents as well. I haven't seen examples in the wild myself of this, but yeah, it's definitely doable. Okay. Sarah, I think you need your 4 minutes to
Exactly, yes.
your things.
I mean, there's not very much that I wanted to discuss, but I wanted to bring to everyone's attention that thanks to Peter Desmet, we now have a full comparison of data package with CSV on the web. So I'll put a link here. It's in the data package documentation, but that could probably be very useful also to replicate for other standards that we want to compare with. And in the past, I mean, Keith is not here, but he was very keen on having something like this for row crates, for example. So we could definitely think about using this as a model for like further comparisons as well. So have a look. And then the other thing, basically, I'm kind of like carrying a message from Evgeny here, who basically said that the new contribution guide is also almost ready. And I'll put the link here in the chat again. And basically, this should help us working on the new versions, starting from the version 2.1 of data package. And maybe we can use also this voting mechanism with to vote for issues that we want to support in this GitHub repo here. So if there is anything there that you think, like any proposal that you think you would like to support, make sure that you voted for it, so that it can go up and hopefully it can be picked up in the next iterations. And yeah, so I didn't need more than 2 minutes actually. So. Wait, Peter. And then the only other thing that I wanted to announce, so the next community call is going to be on the 28th of November. So in principle, I had Kyle and Albert Jan, I had you down for a categorical group, categorical data working group presentation. I don't know if you're still up for that.
Oh, we can talk about that in the Slack.
Yeah, do that.
Okay, because the other thing that I had in line was actually to have also a quick presentation of the pre-release of Open Data Editor. So basically, the application will be stable released on the 1st of December. And Kyle, I remember that I promised you that I would send you some documents about that, and I haven't done it yet. So I promise I will do it today.
Cool. Yeah, we may need an extra month on the categorical presentation.
Yeah, absolutely. I mean, if you want, I can put you down for the presentation in December, and then you can just confirm if that's still the case. We can also move it to next year if you need more time.
Okay, cool. Yeah, let's talk more in Slack.
Great. And yeah, I think that's it for me. I don't know if anyone here had any other questions. Yes, Etienne.
Well, I am interested in a graph editor, a visual graph editor, because human can understand a graph and computer can understand the graph and produce a graph. Dus that is useful for man-machine interface. I can misschien maybe share my screen.
Okay, I can give you.
No. You see it?
Mm-hmm.
Dus the human can simply understand a graph. You have a patient, you have you select one, there is a link to temperature, there's links to fever. That is something useful for human, and that is also something useful for computers, because we do not need, in medicine, we do not need artificial intelligence, we need assisted intelligence. And you have to explain why you propose something. And that is a particular application, but I think it is of generic interest for knowledge representation.
I agree with you at the end that this is interesting. I have to admit that I'm not at all a specialist in this, so I really don't know how I can help you on this. But I think that maybe, as I mentioned, if you join the Slack group, that could be a good place to have this kind of discussion. And hopefully there will be people that are more savvy in whatever is linked to, graphs and stuff like this. So I would definitely encourage you to come to the Slack group and ask the question there as well. And I'm sure that other community members will be probably, first of all, happy to jump on the discussion, but hopefully also to help you.
And my background is medicine, and I need help for JavaScript.
Yeah, I'm also like a lot of the people in the Frictionless community are more like savvy in Python and R, but I'm sure that there are some people that are also like more knowledgeable in JavaScript. It's not, we do have a library of Frictionless in JavaScript, but it's not very updated. But I think if you come and ask the question in the community chat, probably there we can find someone that at least can start the discussion, but hopefully also help you.
Okay, thanks.
Thank you. And so thanks. Well, we have not many left. We passed the hours ready for 3 minutes. Thanks again for joining us. And yeah, let's be in touch, and goodbye, Choff, as well.
Okay.
Bye.
That was wonderful, Sarah.
Thank you.
I have a really good feeling about this group.
Great.
Really,
Oh, I'm glad.
Absolutely.
And yeah, also because, I mean, this was more of a meta conversation. Sometimes we have more like technical conversations. It really depends.
Sure.
But we have like monthly meetings. So I'll definitely invite you also to the next ones as well.
Yeah.
Thank you very much. Bye, all.
Bye.
Have a good day. Bye-bye.